Welcome, everybody. Welcome, colleagues. This is a joint talk with my two colleagues, Saksham Atri from India and Aaron Windischbauer from Austria. It's about GNU Aris. It is a web application right now for students. It used to be a native application written in C, but now it's a C++ application for logic teaching at most at university level. Thanks so much, Pilar, that you help us delivering this talk. The logic education software tool, GNU Aris, is quite well known in the free software community. It has been developed since 2011 by a GNU activist, Jan Dunn. It is no longer maintained by him, but the community started to work on the project, and now we have a new version, and we have some new experiences how it works in some school situations, some classroom situations. This development was mostly based on the Google Summer of Code 2023 project, and the biggest aim was to bring GNU Aris a web application, and finally to try if the new features really applicable in classroom situations for university students who attend a logic course. You can ask the question, why another software tool? There are a lot of software tools, for example, the Coq system, Isabel, Lean, and a lot of other systems there to study mathematics or other science research fields. As said, GNU Aris is not really new. Also, we think that the other big players like Coq or Lean or Isabel, so they are very good, very big, but maybe too complex, too big, too difficult for prospective mathematics teachers. So at least these young people who want to teach mathematics for the next generation, they are usually not familiar with programming. So if they come to learn a system like Coq, it's really exhausting. It's really a big challenge, and that's why it seemed to be a good idea to give them something simpler. And the other idea, the other concept is that usually you don't have to give a full system for these prospective students, prospective teachers, because they usually need only a taste of the thing. So they don't have the whole system. They don't want to prove everything in mathematics. They want to study just a small part of, for example, number theory, or a very small part of calculus. It seems to be balanced between these two, to have a quite good working, nicely working system. On the other hand, it should be somewhat limited. So the syntax should be very close to the everyday mathematics, to the school mathematics. But of course, it's quite good if there are still possibilities to reach a high level of mathematics in some sense. Why GNU Aris? Because it's open source. It's complicated enough to tell some more complex stories for our students. But on the other hand, it's not really ready for end users. At least at that time we started this project, we learned that it's not easy to install it, among others. So it has to be compiled, and most students, most mathematics teacher students, they don't have an idea how to do that. Of course, it's possible to compile the software for many platforms, for Windows, for Linux, for Mac, and we did it, but it's sometimes also difficult to do something in the classroom, even for university students, because the computer room is limited for web browsers. So you don't have any access to install new systems, new programs. So it's quite difficult. So a web version seems to be a good option. Then the other thing is that, well, for mathematics teachers, the native tongue, the mother tongue, is of course preferred. Then the import-export part of GNU Aris was also not really standard. It's in XML format. We were thinking about to extend it. And unfortunately, the user can experience some crashes in some situations. Well, in this slide, you can see how the old version looked like. It's a modern system in some sense. So it has a so-called GTK interface. Well, you can see on the top there is a menu. Then the statements that are commented with arbitrary text. Then you can tell if this line is a premise or maybe a conclusion of the order, the premises, and while DM is the De Morgan rule. So any line here is a kind of consequence of the De Morgan rule. Yes, so back to Google Summer of Code. We are very grateful to Google that they supported this project. Mostly the work was done by Saksham in India. It was 3 months of very active work with some support by 2 more students, Andreas Ebertshuber and Alexander Thaler, and I was responsible for mentoring the whole project. We had a work plan. It's necessary when you start the Summer of Code project. It consisted of 5 big steps to create a so-called Qt interface. Qt is a system that allows programming in a framework, C++ framework, and because of that, it was possible to compile the whole system into HTML and WebAssembly, which means much more flexibility. Then the interface had to be polished a bit. We published the new version, and then we started to get user feedback and to fix issues. Maybe you want to know what is this big A here. This is the logo of GNU Aris, and it was designed by Jan Dan, original developer of the program. So he is Saksham. He is a young student in India, and he worked hard on the implementation. He takes the lead now and has some details on the implementation.
I will now explain the architectural design for the Qt application. Here we have tried to emulate the famous Model View Controller framework. So the user's interaction is limited to the view, which in this case is provided by the QML UI. If the user request exceeds capabilities built into the UI, then the request is forwarded to a C++ controller layer along with the relevant proof data. This middle layer now processes the data into appropriate C data types and forwards it to the C logic engine. We are reusing the old logic engine by decoupling the GTK UI with program logic. Thus, the generated results are communicated back to the controller, which then updates the view so that the results are displayed to the user.
Well, the new interface is a bit different from the JTK interface. It was quite important to create a new kind of interface, user interface that is transparent in the sense of working in a native environment, so natively in Windows, on Mac, on Linux, but also to be able to translate it into the web. So what you can see here, this is the native version of the new Qt version, again with the same premises and the same conclusions. Conclusion is the notion here in GNU Aris, and the menu system is a bit different. So here you can open the menu, and also there is a virtual keyboard to enter the logical operations and some other symbols. finally, this button here is responsible for checking if you typed the input correctly or not. So if it is not correct, then you will get a red color here. The other interface, the web interface, is quite similar. Of course, there are some very minor differences. This example here is a bit different, and you can see that there is an option to write the mathematical symbols somewhat differently. Okay, so let's start this program. If you start GNU Aris, well, it's here. Maybe it's not ready. I start it again. So in the background, WebAssembly code is compiled, and here this is one input line. Well, I enter the statement A. I add a new premise statement B, and then I add the conclusion. It's A and B. Okay, so A and B is a conclusion. Now, if I try to check if it is okay, then we get an error message that, well, there is a default rule set and a default rule. And here we didn't really use inference, the inference group and modus ponens, but we used something different here. We used the conjunction. And now, if you click on it, it's still an error because we need to give the references to the premises. So what is the first reference? This one and this one. So the cursor need to be here, and we need to click on the reference. So now we can see that this conjunction is related to 1 and 2, or is this based on these two premises. And if we click on evaluate proof, then we get this answer. Well, if we remove something, we can try it again. You can see that those lines that are syntactically correct, they are still green. Only those lines that have some problems in the background, they are red. So back to the presentation. We managed to hold a series of lectures on logic. My former student and my colleague now, Aaron, was one of these 30 students between October 2023 and January 2024. So he also tried the program, and he gave feedback, and some exams were done by him. Well, this logic course discussed two main topics, propositional logic and first order logic. Of course, 15 weeks are not too much for such big topics. With GNU Aris, GNU Aris was not the only software system we used to visualize, to explain some concept of logic. We used other systems, for example, GeoGebra Discovery, or the set solver, Miniset, Mathematica, Wolfram Alpha for propositional logic too. Here, we would like to illustrate GNU Aris with two examples. One example is from a quite well-known book from Raymond Smullyan, the famous logician, The Lady or the Tiger. And the second example is a well-known basic concept from category theory. So let's have a look. The first example is shown in German because this is how it is authentic. It's about a king who gives a puzzle for the prisoners. So maybe you want to see this question in English. The basic idea will be explained in the next slide. So the king tries to find good puzzles for the prisoners. Well, let me read this. Yesterday was A fiasco, said the king to his minister. The 3 prisoners solved their puzzles. Well, we have 5 trials coming up today, and I think I'll make them a little tougher. Excellent idea, said the minister. Well, in each of the trials of this day, the king explained that in the left-hand room, room 1, if a lady is in it, then the sign on the door is true. But if a tiger is in it, the sign is false. In the right-hand room, room 2, the situation is the opposite. A lady in the room means the sign on the door is false, and the tiger in the room means the sign is true. Again, it is possible that both rooms contain ladies, or both rooms contain tigers, or that one room contains a lady and the other a tiger. So this is the English explanation, the English story of the puzzle. So the puzzle is exactly the 5th trial. The same rules apply, and here are the signs. Signs, at least one room contains a lady, room 1, and room 2, the other room contains a lady. So this is the 5th puzzle. Here you can see the Hungarian version of this book, very famous, very well-known book. And here Aaron shows the German translation, Dame oder Tiger, also quite popular. Now Aaron will tell you some words how he solved this problem when he was a member of this course.
As already stated, this is my solution to Smalian's 5th trial in the web version of GNU Aris. I started with premises which represent the rules of the trial, where L and T followed by a number indicate that there is a lady or a tiger in that specific room. S1 and S2 refer to the signs of each room. Then I initiated a subproof with the assumption of a lady being in room 2. With the rules of the trial, I deduced that the assumption leads to a negation of sign 1, which means there is no lady in any of the rooms. This leads to a contradiction with the assumption that there is a lady in room 2. This figure shows how I used that contradiction, which indicates that a tiger must be in room 2. With that information, I deduced that the sign of room 2 is true, and therefore a lady has to be in room 1. I finished the proof by showing that a lady in room 1 does not lead to a contradiction. A lady in room 1 means that the statement of sign 1 of at least one room containing a lady is true, which does not contradict that a lady is in room 1. The final line is the solution of the puzzle. The prisoner should pick room 1 since that room contains a lady.
The second example about a so-called binary operation, it is denoted by O. It has 2 parameters, and we assume that this operation is commutative because it is assumed for each A and for each B. And we assume that there is a so-called right identity element, which means that for each A, this binary operation delivers A. So this is a kind of neutral thing, or as other formulated, it's a right identity. Then by using some rules, we can learn that for each A, this A operation E underscore equals A. So this is because the second statement, this is a so-called existential instantiation in GNU Aris. Then you can use the commutative property and so on. So for each step there is a rule in GNU Aris, and finally you can learn that there is an F, an element of the main set that fulfills this identity also. So a right identity element is also a left identity element, and vice versa, but it's not shown here. What kind of feedback we get from the other students, from the other 29, and also Aaron was giving some feedback. Well, the error messages are not very easy to understand for simple users. It's for programmers more or less, and not for simple users like prospective mathematics teachers. Then it should be not bad if some more feedback would be given for the user if there is an error. Some devices are not really supported if they have a small display. This is not very good at the moment yet. Changing the language to a different one than English, it's still on the wish list. Copying, pasting, highlighting inputs, or to change the input type of a statement, it's a technical question, but it should be nice to work. And also the exclusive disjunction and the contrapositive, they were missing for many proofs, and therefore our proofs were quite long. Some ideas could be implemented for the next year. So maybe we can have some more reports then. And that's all. Thank you so much for being here. And we want to share some references that could be interesting if you want to learn more on this. Well, we will hopefully continue this project in the next month, and we would like to do some more reports if possible. Thank you so much. We wish you great conference evening and see you soon, hopefully in person.